Hare Krishna. This is my TuneDNA project, and this is the music genre app which has been created by Streamlight. So before running the app, I will show you the Jupyter notebook file, how I train the model. So wait, Jupyter notebook. Okay, so this is my Jupyter notebook, music genre IPY file. So this is the dataset link. You can go to the Kaggle and download the dataset. Download 1 GB, approx 1 GB. Mill spectrogram. You can read how what is mill spectrogram and the ways to create a mill spectrogram. Why we need a Fourier transform and what is mill scale. And Librosa is a Python package for music and audio analysis, because all this thing, otherwise all this thing we have to do mathematically, but here this model has already such a function that you can do anything easily. So library imported visualizing signal audio, how we are and this is the visualization of the audio to signal, and this has been created into chunks so that we can easily classify. I mean, so can it's easy to get a better accuracy. Now this is the mill spectrogram of the first audio, and this mill spectrogram is divided into lots of chunk 1, 2, 3, 4 and so on. See, when we see this mill spectrogram, it's hard to analyze what is in this mill spectrogram. So if this is converted as chunk, the width is increased and we can easily see, I mean the CNN is easily understand that what is going inside, and later the prediction is more accurate. Now these are the chunks, and load and pre-process data, and these all things are done. This is the convolution layer we have added, like how we are building the model. So first we model equal to TF2 as model sequential, and then we add convolution like filter, kernel size, again filter, activation, ReLU function every time, and in the between we add a model.add dropout to solve the problem of overfitting, so that the data do not get overfit. So 30% of the data drop it, again in here 30% of the data drop it, make dense, activation every time, ReLU, and in the end we use activation soft max, and so that to get a better accuracy. And because every time we have to set the parameter different value to get a different which parameter it's having good accuracy. So these are the things summary, and at the end this is the confusion matrix, how the things are going on. I mean, what is I mean this is the actual class, this is the predicted class, so you will know what is confusion matrix. So and now this is my music genre app, and let's run Streamlight, run music genre app. So this is Streamlight. Drag and drop file here. So we will browse item. Here I have saved some file. This is the rock music. Let's see whether it's classify rock or not. This is the way to play audio. You can play predict. So see, when at the time you are predicting, here you can see these all things are running in the behind. See 1, 2 and 3, 20 millisecond per step. So it's predicted. Yeah, it's a rock music. Again, let's see whether it's able to predict classical or not. Let's see whether it's predicting. So as you can see, it's taking some more time now. For classical it's predicting jazz music. So obviously not every time it will predict the good. And let's check one more, and this inner emotional, I don't know, this is different file. Let's see whether what it predicted. Emotional ambient pop, obviously. Let's see. Oh, so hip hop. So maybe pop and hip hop are somewhat similar. So okay, it's predicting good. For your more understanding, let's predict something else more. I have empty folder here. Testing sample again. One predict. So it's predicting rock music. So what I am saying, somewhat it's predicting something different for different music. So as you know that a music, not all music have only one category. Some most of the music have lots of category, like in some music there will be a rock, pop, sad, beep, I mean 4 category are there. So when we divide it in chunk, then one chunk says that it's a rock music, one chunk says that it's a different music, instrumental music. So it may gonna confuse. Okay, so later we can improve this project to work, I mean which is the, I mean how many part is the rock, like suppose a 4 minute video. So to improve that model, we can say later, I mean to improve this, when we improve this, so we will say that the first minute is this type of music, the second minute is this type of music, and the rest of the minute has different type of music. So later we can improve this. So now this is all what I have. So thank you. This is the demo, I mean this is the overview of the project, overview of my project. You can see this is the URL, google.com uc file id. This is my URL of .h5. Actually now, when at the time of uploading it into GitHub, so GitHub has a limit of 25 MB. Obviously I can put 100 MB by using git command, but I have uploaded this h5 in my Google Drive, and using zdown, import zdown, using zdown I have downloaded from the Google Drive. And if the this music genre classification model.h5 is in the file itself, then it's not gonna to download. But if it's not in the file, then it will download from my Google Drive, and then it will use that h5 to predict our, I mean our music. So here you can see it is a file. Okay, thank you. By the way, I'm Himanshu. My name is Himanshu Datta from Patliputra, Bihar. Okay, thank you.